And we're not done with BigTreeTech board configs yet. Today we circle back on the BigTreeTech mini board with a Marlin config. I've been doing a lot of Marlin configs here lately on the channel, especially surrounding the BigTreeTech SKR mainboards. I just got done with a 1.4 config, and the biggest suggestion on those videos was how about you do one for the mini board. Now I did do a video a while back around the mini board, but it was just the hardware portion. It's a direct swap out board for your Ender 3. It even has pre-configured firmware for it. So it's a direct replacement. You swap it in and you should be good to go. But a lot of people want to alter that config, and there's a lot of questions on how to do that. So that's what we're going to do today. We're going to walk through all the steps you need to do to get Marlin firmware flashed onto your mini board, make some changes, and use centralist homing on the integrated version of that board. So let's start this video with a bit of a recap on what those two mini boards look like. So just a bit of a recap on the mini boards before we get to the Marlin config. There are two different ones. The main one we're going to be focused on today is the one with the integrated 2209s. That's the Mini E3 version 1.2. But you also have this version, which is the SKR E3 DIP version 1. It has replaceable drivers. So you don't have to use those 2209s, you can use whichever driver you want. When you're configuring drivers on this board, it's going to be almost exactly like the 1.4 turbo config. So you change jumpers around, you modify some of the pins. That's how you would configure them on this board. And the only other main difference in between these two is they have just a little bit different processor. They're both STM32 chips, but this one has the RC version and this one has the RE version. And if you go look up the specs on those two chips, it lists the RC as having 256K of memory and the RE as having 512. But by playing around a little bit, it really doesn't seem to matter how you flash them. They will both accept 512 of memory. So going forward with the configs, we will be flashing both of these as a 512K board. There's probably a lot more information to go along with that, but it seems to work either way, so that's how we're going to continue. Now on to the Marlin config. As always, the first thing we want to do is head out to marlinfw.org and grab the newest version of Marlin. A lot of times, just upgrading to the newer version of Marlin can fix a lot of issues if you have them. The Marlin team is currently very active at fixing all the different bugs that are introduced in some of the software, so always go check to see if there's a newer version. Currently, we have 2.0.5.3. We'll just download the zip. We head to Downloads, right-click on the zip, extract all, and we'll just call this one 2.0.5.3 underscore SKR underscore mini. We hit extract, we'll wait for this to complete. The extraction is complete. I'm going to go ahead and rename this folder inside of our parent folder, just so I don't get confused while we're working on it. I'm just going to name it to the same thing, 2.0.5.3 underscore SKR underscore mini. We can go ahead and head into this folder, and we're going to head into the Marlin folder. Now this is where the configuration files live, including your INO file that you can use in your IDE editor, but we're mainly concerned with configuration.h and underscore adv.h. Now because the Marlin community is so awesome, there's a lot of people out there that create specific configuration files for specific printers. And the Ender 3 is very popular, so you know there's going to be a configuration out there for it. So that's a great place to start when you're building for a specific printer if you don't have any modifications, or you can just tweak them a bit after you build it. Those configuration examples currently aren't included with the Marlin build. You have to go back out to GitHub and grab them. But it's easy enough, so let's head back to the browser. And we're just going to go to the Marlin GitHub. Marlin GitHub. And here in the main directory, if you just go into config, it's going to give you the link to where all the examples are. It's just an archive file, so we'll download this. Again, back to downloads, we'll just right click and extract it. And we can open this up, and here's all the example configurations. We can open this one up, and then go into config, and we'll go to examples. And here's all the different manufacturers that have example configs out here. We want Creality, and here's the Ender 3 config. And here's all the configuration files, including the boot screen and the status screen, that you can use for a stock Ender 3 config. This is the best way to just get all those default settings out of the way. Somebody's already done all this work for you. So we're just going to copy all 4 of these files. We'll head back to Downloads, go into our new Marlin configuration that we haven't edited yet, into the subfolder, into the Marlin folder, and we're just going to paste all 4 of those files right here. And we're going to replace the files in the destination, so we'll overwrite the default ones. Now we have a lot of this work already done for us, so we don't have to go through this line by line. This is super handy. But we will need to make some updates because we have an updated board. This is going to be just for the Creality board. So let's open up VS Code, and I'm going to add a folder to our workspace. I'm going to head to Downloads. I'm going to go into my Mini folder, and you want to add that subfolder, not the parent folder. Remember, in this subfolder, that's where the Marlin config is. In VS Code, you want the parent folder of this Marlin folder. So whatever folder is a level up from this Marlin folder, that's the one we want to add. So we'll go up one, and we'll add this one. We'll hit Add. If you don't get the right folder, you're not going to see the correct configuration and you can't build it. So make sure you get that step right. And we're mostly concerned with configuration.h and _adv.h. So let's start in configuration.h. Now again, a lot of this is going to be exactly the same as the 1.4 SKR videos. There are a few different things because we are using a different processor, but I'm not going to go through every step line by line. I'm just going to show you enough how to take this default Ender 3 config and get it working on our SKR mini board and use some of the features that that board has. Again, if you want to know about a lot of the Marlin features, you can check out some of my other videos, including the series for the SKR 1.4. So let's get to the configuration. We'll scroll on down, we can see we're on version 2.5. This Ender 3 config was built by Keith. Thank you, Keith, for building this. I happen to know him. Go check him out on Twitter and GitHub. And since the config was built by Keith, I'm just going to keep this author information in here, but I'm also going to add SKR Mini. So if I look for this later, I know which one that I added the mini board to. We'll keep on scrolling. Since we've got the stock screen and all of that, I'm going to keep all of this the same. Serial port I will change to -1 because we're running a 32-bit board. I'll leave the baud rate the same, and then we have to change the board up. This is the current Melzy Creality that you get in the Ender 3. If you need to know what board to use, we go to Source over here, go to Core, and go to Boards. They are listed by processor. We'll scroll down. Our mini board has an STM32 processor. If you're using the mini board that has the integrated 2209s, you're going to want to use this board. This is the most current version of that board. That's the one we're going to use today. But if you want to use that DIP version, the one I showed you at the beginning of the video that has the swappable drivers, you will use this one. And I'll show you more on that in a minute. But let's go ahead and get this integrated version set up and running and make sure we can compile it before I show you that. So we've got our board back to configuration.h. We're going to paste it right here. And most all this other stuff is going to be exactly the same unless you've upgraded your printer and changed things up. This is the stock config. It should work just like this. So with no other changes, just that board updated, we should be able to compile it and use the firmware as is. So let's just go ahead and test the compile. We'll come over here to the platform IO. Up top here, we're going to have to find our environment. For this one, we're going to go with this STM32 F103RC BigTreeTech 512K. Expand that one, and let's just hit build. And the build was successful. Let's go ahead and upload it to the Ender 3 just to make sure that it's going to work. With the STM32 boards, you're going to have to hand truck that firmware bin file over to your SD card, load it on your printer, turn your printer on, and then that will upgrade the firmware. I know that there are adapters and a couple of different paths to make this SMT32 work with serial. I'm not sure that it's ever going to be possible on this board. Please, if you do know a way, correct me if I'm wrong. But for updating the firmware on this board, we're going to have to go with the firmware bin file route for now. So I'm going to take the card out of the board and mount it on my computer. Here's our card. I've got a bunch of G-code files on it. They can live there too. It's no big deal. Then we'll head back to VS Code. We'll go back to the File Explorer up here in the top left. We'll scroll up a bit. And we're going to find our PIO folder. We'll expand that. We're going to expand build, and we built for the BigTreeTech 512, that STM32. We'll expand that one, and we need to load that firmware.bin on our SD card. So I'm going to right click on it. I'm going to reveal in File Explorer. I'll just right click and copy, and I'll paste it on my SD card. Now we can take the SD card out and load it on our board. So we've loaded the SD card on the board that has the firmware on it. And we'll go ahead and power up the printer. And when it boots, you can see we have 2053. That way we know that we've updated the firmware successfully. Now we do have some errors. We have some more cleanup we need to do. But now we know that we can load that firmware successfully. We're updating correctly, so we know we're in a good place. This is a good starting point. Now we can go back and make changes and re-upload. So back to VS Code. Now that we know that we can update that board and compile successfully, let's change up a few more things. It's important to note on the end stops, these are all set correctly for an Ender 3. It should work just fine. But if you're going to use sensorless homing, these two are going to have to be set to false. So if you're using this default Ender 3 config, they will be set correctly. But if you're using something else where these might be set to true, before you use that sensorless homing, these have to be set to false. We'll keep going. Down to stepper drivers. We do have 2209s. So we are going to take the comments off of X, Y, Z, and E0. We're going to change A4988 to CMC 2209. We're going to do that for all four. We're good there. Just scrolling through configuration.h, if you have a stock Ender 3, all you've done is upgrade the board, there really isn't much else we need to change in here. You might want to go ahead and update your filament temps, which I will do. But other than that, pretty much everything else we need to change is in configuration_adv.h. So let's jump into that file. So we'll head back to Explorer up here in the corner, and we'll open up configuration_adv.h. And really there's not a ton that we need to alter in here either, but we do need to change the way the 2209s are going to work, and we want to enable sensorless homing. So let's scroll down to the TMC section. On the way down there we come across home bump. Sometimes sensorless homing doesn't like to bump twice, so I like to set X and Y to 0. This is to confirm the state of an end-stop switch, but we probably don't need it for the 2209s with sensorless homing. So we'll keep going. And then we get down to the section for the 2600 series driver. We need 2209s, so we're going to keep going just a little bit more. And we get to has trinamic config. All the defaults that are in this Ender config should be just fine. They do have the current for X and Y set to 580. It seems to work just fine with this printer. Your micro steps at 16, and it does have interpolation turned on, so you can go all the way to 256 with that software stepping. So that should work really well. Z is also set to 580. And E is set to 650. I would just go ahead and leave these at default for now. You can always adjust these later with some commands, and we'll turn those on here in a second. A user reached out to me on Twitter and actually told me that he had better luck lowering the home current on his X and Y drivers. It limited the grinding. So the lower the current, the better sensorless homing seemed to be able to react when it crashed into the side to check where its home position was. By default, these are set to whatever your current level is set to. So this one's going to be set to 580. But you have the option to lower that to try to increase your accuracy. So this might be something we want to play with. Let's check it in the default configuration for now, so we'll just leave it like this. But if we get some grinding and we start skipping some steps, maybe we'll come in here and lower these so that it uses a lower current when homing only. Down here, we're just going to keep it default. We're going to use Stealth Chop for all four drivers. That keeps it as quiet as possible. For the Ender 3, you do want to make sure you have 24 volt chopper timing set because we're on a 24 volt system. That tries to help eliminate a few issues with the chopper timing running at certain voltages. Sometimes it will introduce even some noise. This should help with that. I'm going to take the comment off motor driver status so we can get some stats on the drivers as they're working in case there's issues. Hybrid threshold we're not going to use. Again, a lot of this information is in the 1.4 videos. If you haven't seen those, go check them out. And then sensorless homing, we're going to take the comment off of that. Install sensitivity, I'm going to leave them default, and we're going to set them command line and save them in EEPROM, because they will more than likely have to be adjusted. But it's a pretty quick process, we'll go through that. The only other setting I want to change is TMC debug right here. That gives us the ability to do continuous reporting on the drivers if we were to have issues. So again, the purpose of this video is to get you in a place where you can alter the config on your mini board for your Ender 3. I'm not going to go over all the different features you can enable. That is in other videos and more will come. I know a lot of people are interested in the BL Touch. I do have 4 different versions of that sensor right now ready to start making a video on it. So in case there's issues on different versions, we can go over that. So that will be a future video as well. So the config looks good. Let's go ahead and build it again and make sure there's no issues. We'll go to Platform IO. And we're going to keep it on that same RC board, and we'll just hit build. We have built successfully. Now all we have to do is copy that firmware bin file over to our SD card. I'll show you that one more time. Go to the Explorer. It's in your PIO folder. It's in Build. It's in the processor that we're using. Firmware.bin right here. I opened an Explorer. I'm just going to copy it, mount my SD card on my computer, and you'll notice on that SD card that our firmware.bin file is still there. I don't know what's up with this board config. It's the only one I've ever seen do this, but sometimes it doesn't do the cleanup portion after it's upgraded the firmware. It'll pull in the firmware update just fine, but it won't delete the bin file, and sometimes, like this case, it won't create that CUR file, or the current file. I'm not sure why that is, but after we load it this next time, I'm going to go ahead and go back and clean it up, because if you don't, it will try to upgrade the firmware every time you power it on. And while it might not be a huge deal, it might cause some issues with EEPROM, and it also takes a while. So for now, I'm just going to delete the one that's on the SD card, and I'm going to put my new one on there, and then we can load this SD card in the printer. Now to use sensorless homing on this board, there is one more step we're going to have to take, and that's on the board side, the actual hardware. Now I'm going to show you this part on my extra board because it's easier than looking inside that compartment. Now with the DIP board, you have jumpers, and you can control how sensorless homing and different attributes of different drivers are set with the pins and the jumpers. On this board with the integrated 2209s, you don't have that feature. But you do have exposed pins here that you can use. For each one of the 2209 drivers, you do have a diag pin, an index pin, a clock pin, and a VREF pin. And this is how you're going to communicate with those integrated drivers. You don't have the jumpers like you do on some of the other boards. And really the only data that we're interested in is that diag data, so we can use sensorless homing. So to make that work, we're just going to use a couple of female-to-female jumpers. We're going to take the X diag pin right here, and we're going to run it over to the X in-stop signal pin. Make sure you're on the signal pin, not the ground pin, just like that. And then for the Y, also we're going to use the Y diag pin, and we'll run that over to the Y signal pin on the in-stop. Now the in-stop signal will get the feed from that 2209 when it triggers that sensorless homing, and it should work. Now I'm going to show you how to do the same thing on the board that I have installed in the printer right now. Again, it's going to be pretty hard to see in here, that's why I showed you on the bare board, but we're going to remove the X and Y in-stop wires. There's X. There's Y. And just like we did on the other board, I'm going to get the diag pin off of X. It's hiding back there. And I'm going to hook that up to my signal pin for my X in-stop. And I'm going to do the same for Y. It's even harder to see. There's the Y diag pin. Over to the Y in-stop signal pin. And that's all you should have to do to get up and running for sensorless homing. And just because we can't flash the firmware via USB doesn't mean that we can't communicate with the printer via USB. I am still going to use Pronterface to do some of the configuration, so I'm going to cable that up. And I'm going to power the printer on, and we'll start some testing. Now that we're powering up and we've already hand trucked our SD card over to the printer, it's going to load our newest version of firmware that we've enabled to sensorless homing and changed up to those 2209 drivers. So we'll open up with Pronterface. We can go ahead and connect up. We're at 11.5200 baud rate, COM12. We'll hit connect. Printer is online. To get rid of that EEPROM error, I already did this in the past, so you don't see it right now. But if you have that EEPROM error because you've uploaded new firmware, all you have to do is reload the existing firmware into EEPROM. So just do M502, that brings in the defaults, and then M500 to save into the current EEPROM. That'll get rid of that error after your next reboot. And now we can take a look at M503. That tells us all the settings that are currently in EEPROM. So we've pulled all the defaults. The one we're most concerned with right now is this M914. That's the stall guard settings. That's what sets how sensitive sensorless homing is. The lower you go, the less sensitive. The higher you go, the more sensitive. All the printers I've tried this on so far, if you leave it set at 8, you're going to get crashing. So why not, let's go ahead and test it. So let's just auto home all. And there's the crashing that I know so well. So we'll power off. So M503 again, most i3 Cartesian machines, I like to start anywhere from 60 to 80 on that sensitivity setting. So let's just change both of them to 60 for now. We'll do M914, X60, Y60. Let's hit enter, and let's try our homing again. I want to move the axis out so we get a good run just to make sure that we're homing correctly. We'll go ahead and try homing again. And that seems to be just a little bit too sensitive at 60. It didn't move where it needed to move. So let's bring it down to 40. And we'll try homing again. And we had just a little bit of grind, but it's much better. So let's move out one more time. Let's try 45. Still just a little bit of grind, but there's really no science to this. So just try and work with some settings that work for you. Also, go back in and try to adjust that homing current if you'd like. Lower it down to see if you can get that grinding to go away altogether. I'm going to go ahead and save that in EEPROM with an M500. And also, don't be afraid to check out a lot of these other settings that we enabled when we did enable the TMC drivers. For instance, M906, if you need to set your motor driver current on the fly, you can use that setting. M122 will give you some debug info about those drivers. You can see all of our connections are good. And you can get your stall guard results up here. So that might help with tuning. And you can grab a report if there's any heat issues with the M911. We haven't triggered any pre-warn, so we're good there. And the last thing I want to do is just to try to test a print to make sure I don't need to adjust any motor currents or anything like that. So we'll preheat up. I'm going to go back to the computer and slice up a Benchy, but I also want to mount that SD card and check its current state. Remember, I told you that bin file sticks around for a while. So let's open that up. And sure enough, we do have a firmware.bin. So I want to change that. I'm just going to make it CUR because that's how it usually handles these files. So that'll be your firmware current file. But now you don't have a bin file on here that's going to try to upgrade the printer every time you boot. So that's been taken care of. I'm going to go ahead and export my G-code onto my SD card. And we're ready to kick off a print. And it looks like we're printing successfully. It looks like my Hotends fan might be getting ready to go out. That might cause us some creep, but we'll go ahead and let it print. Everything looks good so far. Now while the test print is running, I did want to go back and talk about that other board, the DIP board with the replaceable drivers. If you want to use that board, you can use this same config. You pretty much just have to change the motherboard name. And again, if you need to know what those names are, you can just jump over here to Source, Core, Boards.h. It's listed by processor. They have the same STM32, although they are just a little bit different model. I'm not sure that it really matters at all. But that DIP version is this one right here. So we'll copy that board name. We'll head back to configuration.h and we'll paste it right here. And if you have that board and you want to build for that one, we'll go back to Platform IO. We'll collapse the RC version of that chip. And we're going to find the RE version of that chip. We do have the RE BigTreeTech right here, but we also have one that says BigTreeTech USB. The USB should include all the software serial libraries, so you can talk to it via Pronterface. We'll expand that one, and we'll hit build. And the build was successful. Both of these should work, the BigTreeTech and the BigTreeTech USB, just like above, up here. But I have a lot more luck with this one with USB. It doesn't complain about that software serial when you compile it. So go for that one if you have that board. And that should be the only difference in between the DIP version and the 1.2 version. If you have issues with the 1.2 version, that RC version of the chip, you do have those options up here for USB and the 512K. Again, I think the only difference is the software serial libraries, so go for this one with the USB on it if you're having issues. And we tried, but our failing fan and our heat creep caught up with us. What we have looks pretty decent. I'm pretty confident our changes are working. Definitely going to have to work on that fan. And there it is, the BigTreeTech SKR mini board Marlin config is complete. I did try to complete a print on this new configuration, but the hot end fan on this printer is going out and heat creep caught up with me. But I am pretty confident that that's not related to the board config and it is working correctly. Now I do intend to do quite a bit more content around this configuration, especially where BL Touch is involved, because I get a lot of questions about that sensor. So we'll do that for sure, as well as a few add-ons for these boards, including a Wi-Fi module. So stay tuned for that. Hopefully you found this video helpful. If you did, please consider giving it a thumbs up or subscribing to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.